today we discuss a photoelectric effect and wave theory of light. Okay, so discuss photoelectric effect and wave theory of light. Okay, so previous class we discussed photoelectric effect. What is photoelectric effect? Okay, we know that the concept. Okay, so here we know that light have dual nature. Okay, they have dual nature. One is a wave nature and other is a particle nature. So wave nature we study. Okay, so as a Huygens principle. Okay, diffraction, interference. Okay, polarization. These are the wave nature of light. But here we discuss particle nature of light. So photoelectric effect is the particle nature of the light. Okay, so the photoelectric effect is particle nature of light. Nature of light. Okay, so here what is the particle nature of light? So before that we will discuss some particle nature of light. So you know that, first recall that previous class. Okay, what is the photoelectric effect? Okay, so here first draw a discharge tube. Here. There is a two metallic plate here. Okay, metallic plate, and there is some open here, some window here. Okay, window, and this UV ray falls from this window, quartz window, and fall this metal plate, and here is this metal plate connected to negative polarity. Here there is a positive, so some electric field in that direction, plus to minus direction. Okay, so these metal have some free electron. Okay, this metal have some free electron. Okay, and this UV light falls on this metal surface, and this electron gets some energy. Okay, and this energy is greater than work function. If the energy of an electron, this free electron, greater than work function. Okay, so if the energy, this energy is greater than work function. Okay, energy is greater than work function phi naught, we get photoelectric effect, because this electron is a jump from that a pulling, okay, pull attractive pull, and move towards that plate. Okay, suppose then this plate is accept that electron is called acceptor plate, and this plate emit the electron is called emitter plate. We know that concept actually from previous class. This electron jump, when this metal lost electron, we get a metal get positive and electron get negative, so there is some attractive pull, and this electron get from enough energy. Actually that enough energy means that more than work function, of metal. Actually this work function is attractive pull. Okay, more than the attractive pull, this electron move towards that acceptor plate, and we get some current here. This kind is called photocurrent. You know the concept. What is a photocurrent, and when you get a photocurrent? So there is a two important factor. This energy obviously greater than work function. Okay, so maximum energy of photoelectron. These are the maximum energy. When jump from here, so you get maximum energy of photoelectron. So maximum energy of photoelectron move. So electron move from this work function energy greater than work function. So this there is some energy and there is some kinetic energy maximum. And this energy obviously moving. There is a half mv square. So that's the velocity here. The electron move that velocity released from emitter plate and move towards the acceptor plate. That's the basic photoelectric effect. When the electron goes here, we get some current, and this electron is called photoelectron, and this current is called photocurrent. So no photoelectric emission is possible when that a large number of electron energy absorbed but less than work function. Okay, so no photoelectric is possible when the energy, if energy large but lesser than work function, so photoelectric effect is not possible. So here the possibility when when the energy is more than work function. This energy absorbed by the electron is more than work function. So large number of electron absorb that energy, and this electron absorb the energy per unit time. It gets a more photocurrent. If electron gets more energy, means more number of photoelectron possible. If more number of photoelectron possible, so more photocurrent we get. So here large number of photoelectron, so large number of photoelectron, okay, large number of photoelectron uh, actually absorb the energy. So photoelectron the electron absorb the energy, okay, and this electron absorb the energy, mainly the photoelectron absorb the energy, the energy from UV ray, this UV ray, to jump to overcome that work function, okay, and you get more photocurrent, more photocurrent. It is all possible, okay, when electron treated as a particle, okay. This possible, mainly this possible when you treat electron as particle, not wave. So that's why starting class we discuss the light have dual nature, wave nature and particle nature. Okay. So now electron treated as a particle, not wave. So if a electron is a particle, then photoelectric effect is possible, otherwise not. So here comes the Einstein photoelectric equation. That's very important. And energy quantum of radiation. Mainly today's discussion topic. Here is the Einstein photoelectric equation. The famous Einstein photoelectric equation. Okay. Or energy quantum of radiation. Energy quantum of radiation. Okay, so the name Einstein, you know that the famous scientist Einstein, and this quantum means a very small particle. Okay, this quantum means a very small particle, very small particle, like electron. The mass is 9.1 into 10 to the power minus 31 kg. If you imagine that, that's a very small, very tiny particle. That's why this tiny particle is called quantum particle. Okay. So photoelectric emission, okay, mainly important concept here, discussion here. The photoelectric emission does not take place by continuous absorption of radiation energy. Okay, here comes the things. Okay, that main concept is that the photoelectric emission does not take place by continuous absorption of radiation. Okay, radiant energy. Okay, this energy, actually this UV energy, you see that is a continuous, but actually not continuous. These are the discrete. Okay, so here the photoelectric emission, the photoelectric emission does not take place, not take place by continuous absorption of radiant of radiation. Okay. This radiation energy build a discrete unit energy. This radiation energy, this radiation energy is built of the discrete unit of discrete The mainly important concept. These energy build up a discrete unit. Okay. So this energy so called is called quantum energy. So this energy is called quantum energy. Okay, this energy is called quantum energy. Okay, so clear. What is quantum energy of radiation? Energy of radiation. So here you see that the diagram. So these UV ray fall on this diagram, fall on this metal surface is not a continuous. Einstein said this is a discrete quantity. Okay, if I treated the electron as a discrete, so there is a discrete. When electron is a particle, so electron move from here, from emitter plate to acceptor plate. These are the discrete here. Okay, electron, a group here. Okay, these are a group of electron move from emitter plate to acceptor plate. Okay, these are called a discrete, and this group is very, actually these are very small. So you consider this whole group is a one discrete unit, the plus 1, minus 1, plus 2, minus 2, plus 3, minus. These are called discrete quantity. Okay, each quantum energy. So mainly this UV ray falls on. These are the a discrete. Okay, these are not a continuous absorption energy. These are discrete energy. These are the discrete energy. Main concept. These are the discrete energy. On each quantum energy. Okay, so each quantum energy mainly discrete. Okay, so the energy is, that is E, that is equal to h nu. Okay, so this h is a Planck's constant. Planck's constant is a name after Max Planck. Okay, this is a scientist name, famous scientist Max Planck. The Planck's constant, and this nu is the frequency. It's the frequency of light. Okay, so when electron absorb the h nu energy. So here is a, can you draw? These are metallic surface. These are another metallic surface. These are the UV ray. Okay, so here is the electron absorbing energy. These are the h nu energy. We say now it is because the UV ray is not a continuous. These are the discrete. So there is some h nu energy, and that is equal to h nu. That's also an Einstein equation, equal to h nu. And this energy. So when is electron absorb h nu energy, okay, and this absorb energy more than work function, obviously. Okay, when this energy is greater than work function phi naught, so then this electron, okay, escape from metal surface, and this metal, this called emitter, emit from this metal and moves towards, moving towards acceptor plate, this electron, and there is some polarity, obviously. There is some electric field here. Okay, so here now when electron move in that direction, emitter to acceptor, so the absorbed energy is more than work function, and electron emitted by the maximum kinetic energy. This electron is a maximum kinetic energy, and this maximum kinetic energy mainly concept is, and these UV ray absorb energy, these h nu absorb energy. Okay, UV ray absorb energy by absorb energy in form of UV ray. Okay, UV ray absorb energy h nu. So UV ray, the frequency is the h nu. That's the absorbing energy h nu, and minus work function, and that's that minus we get a energy, and that energy electron move from emitter plate to acceptor plate, because that is equal to half m v square. So you get a maximum velocity here, obviously mass constant, so you get a maximum velocity, and electron move that velocity to from emitter to acceptor plate. and this intensity, and here is another factor is the intensity. So intensity of determine the UV light. Okay, here is some intensity. Basically this intensity determined by UV light. Okay, so number of electron. So number of electron emitted by the metal surface per second. So that is obviously a photocurrent. Okay. So number of electron emitted by metal surface per second. So number of electrons is more, so photocurrent obviously be the more here. So kinetic energy. So here the K max, this kinetic energy of the electron, okay, determine the energy of each photon. Okay, so here you see that electron move from this plate to that plate. Okay, so this kinetic energy, okay, these are determine energy of each photon. Determine energy of each photon. Okay. So these are the energy of each photon. Okay. So this kinetic energy maximum determine the energy of each photon. Okay, absorbing each photon energy. Okay. So light, when you treat it as the electron is a particle nature, so that's why these are a photon. Okay, photoelectric effect. Okay, so light nature is a phonon and particle nature is a photon. So further we discuss what is phonon and what is phonon, but here we discuss the kinetic energy determine that each photon. So K max, okay, this K max directly proportional to intensity of incident radiation, mainly UV, right? So more intensity means more kinetic energy maximum. So photoelectric effect is possible of single quantum radiation by single electron. If single electron move from emitter to acceptor plate, we get photocurrent. So obviously single electron also gets some energy by absorbing by UV ray, and this single quantum radiation by single electron also get a photocurrent. Okay, so here the photoelectric effect possible. Photoelectric effect possible, actually we discussed mainly the particle nature of light. Okay, so mainly particle, establish the Einstein equation, mainly focus to particle nature of light. So our discussion must be try to prove that the Einstein equation is true and the photoelectric effect is possible and electron possible when we treated electron as a particle. Okay. So photoelectric effect is possible when the absorption of single quantum radiation by single electron. So intensity of incident radiation, okay, that is directly proportional to number of energy quanta per time. Number of energy quantum per time. So photoelectric effect is possible. When the photoelectric effect is possible, when h nu, the energy of a UV ray is must be greater than work function. So this work function also be the energy. So this is also the Einstein equation here satisfied here. This Einstein equation equal to h nu mainly. Okay, that is work function phi naught, that is also h, Planck's constant, and the nu naught. This figure, these are nu naught and this nu naught is called threshold frequency. And you know that the threshold frequency concept from previous class. So here this h nu is must be greater than h nu naught, h be the cancel. So you get nu greater than nu naught. Okay. So the greater the work function, the higher the minimum the threshold frequency. So when we try to that photoelectric effect, we get photo current. So UV ray, okay, the frequency of UV rays must be greater than the threshold frequency. So if the greater the work function, we need a minimum or threshold frequency. Okay, minimum and threshold frequency. So we need higher minimum threshold frequency. Okay, so actually that is nu naught, that is h by sorry, that is equal to phi naught by h. Here you see that. Okay, so if the work function is higher, so okay, suppose the work function phi naught is large, so you need a more energy. More energy means a more minimum energy, obviously. The more minimum threshold frequency of incident light. If work function more, so that is a phi naught be the mode, and for photoelectric current we need, if this frequency be the mode, much higher frequency needed here. So below that that threshold frequency or work function, we know that photoelectric effect is not possible. So we need higher minimum threshold frequency for greater work function. For more greater work function, actually this work function determines the metal properties. Okay, the fixed for is a constant for single metal. For sodium or work function is fixed, aluminum is fixed. Okay, the magnesium is a fixed. Okay, so work function is constant. We need a higher minimum threshold frequency to overcome that work function. Okay, overcome that work function or threshold frequency for photoelectric effect. So here there is absorbing energy. Clear? So here mainly the concept is the absorbing energy. That is the important concept. Absorbing energy. This absorbing means energy quanta. This is energy quanta. And that is a nu is greater than nu naught. This concept, nu is greater than nu naught. And the photo current is directly proportional to intensity. Okay, intensity. So here that the process, okay, the photoelectric effect is a process, and electron treated as an element, okay, is a particle nature. Okay, so these are process called the elementary process. When electron treated as an element, so this process is called elementary process. Okay, so photoelectric effect is now an elementary process. The elementary process. Okay, is actually a photoelectric effect. Elementary process. This mainly involved absorption of light quantum by an electron. Mainly involve absorption of light quantum by an electron. Okay, so when the electron, we know that from when electron move from emitter plate to acceptor plate, so electron there is an electron absorbing energy from UV ray. There is no energy. These are not a continuous, these are discrete. So electron released from that metal, this also be the discrete. Obviously electron is a discrete number. Okay, so here these is not a continuous. Okay, these are also with the discrete. So when it is a electron, the elementary process, electron it is a particle. These are process of this elementary process. So these are called discrete. Okay, so absorbing the light quantum by a single electron. The only concept is that a single electron. Okay, So by an electron or a single electron absorbing light quantum by a single electron, now we get Einstein photoelectric equation. So the Einstein photoelectric equation is that, so there is the energy, kinetic energy maximum for that electron, that is equal to h nu, that is from UV ray, okay, minus work function. These all are in energy term, and this energy, that is E V naught, that is equal to h nu minus phi naught, and this E is the elementary charge, so that is V naught, that is h Planck's constant by E nu, and that is and you see that that equation is called Einstein photoelectric equation. Okay, that is a V naught, that is equal to h by E, there is a constant, nu frequency, the variable here, and the phi naught is the metal work function, constant, E elementary charge is also constant. Okay. That is the famous Einstein photoelectric equation. These are the Einstein photoelectric equation. These are Einstein famous photoelectric equation, and you see that that equation is look like y equal to mx plus c, a straight line equation. So if you try to plot that equation, suppose if you try to plot here, so V naught and versus frequency here. So diagram is look like this, straight line, and now okay, the slope of this line, that is actually m, that is equal to h by E, Planck's constant by elementary charge, that's the fixed value here, and this cut point from C, that is actually meant, that is pi naught metal work function by E, pi naught by E. That's the diagram here. Okay, there's the Einstein photoelectric equation. Here comes the fun fact. The fun fact is that the Millikan, we know that a famous scientist Millikan, he performed a series of experiments on photoelectric effect. Okay, his main target is disproving the Einstein photoelectric equation. Okay, they try to have too much experiment and solve that and numerous equation, and mainly the focus is disproving that Einstein photoelectric equation. Mainly target of Millikans. Okay, so they use sodium. So actually he know that some Millikan use the sodium and use the E. Mainly you know the E is a elementary charge, that is 1.6 into 10 to the minus 19 coulomb, for electron is a minus, and he tried to calculate the Planck's, actually try to calculate the value of this H, and he mainly determined that this H is not a Planck's constant. But when after some experiment, when he calculate that value of H, he get H equal to 6.6 to the 4 or 5, 10 to the minus 34 joule second. Okay, and that is the original Planck's constant value. That's the original Planck's constant. These are the Planck's constant. Okay, so finally he got some value, and finally Millikan proved the validity of photoelectric equation. But actually he tried to disproving that, but finally he proved that or strongly validate that Einstein photoelectric equation. He proved the photoelectric equation finally. Okay, so Millikan proved that Einstein photoelectric equation. Okay, that's a very important Einstein photoelectric equation. That's very important in our board exam, JEE or NEET exam, obviously. Okay, so if you have any doubt, please ask in comment section. I will try to give the answer. Okay, So next class we discuss a particle nature of light or photon. Photon. Okay, what is a photon? Mainly discuss on photon. Okay, so here just electron treated as a particle, and next class we discuss more about that photon or particle nature of light, or mainly the electron here. Okay, so today in the class here, if you have any doubt, please ask in comment section. Okay, today in the class here. Thank you.